Okay. Oh, the ears. It makes a big difference with the ears. Someone else came in and donation. Ow. She's wearing black and white with spots. And my other student didn't have the cow ears. I don't do the swimming. No. I am related to people that come to Swimming Nationals every year. They stay at my house, and as a present, they give me a shirt. It has nothing to do with swimming. What I do is control non-drowning, not swimming. Okay, so 7.3 is the last of all the new material that is in AD. So we'll have a test the end of next week.
Wait, I do. What day? It's Wednesday, right?
I believe Wednesday.
No, it's
Thursday,
attached.
I'm gonna die.
Yeah. I
Yeah.
thought it was on Thursday. It's on the 29th.
Can't be on Thursday because Thursday is the very last day of the quarter. We need to have things graded and in. 7.1 was on net versus total. Like, by that I mean integrating from A to B. The velocity is how much did your position change over that amount of time. And total is if you did the absolute value of that, and be very careful with your absolute value bars, that's what your Fitbit tracks. So even if you ran around the track 8 times and your displacement is 0, you actually ran 2 miles. So that's 7.1. 7.2 was area between curves. And you might have to do top minus bottom. Or if it's functions that go this way, right minus left. So 7.1, net versus total. 7.2, area between curves. And then 7.3 is all kinds of volumes. We've done a few of those. 7.3 is volumes of known cross sections. That's the, triangles are popping up out of this shape. Or maybe they're squares, or maybe they're rectangles. And maybe they're going sideways like this, which you need to know that those make dy slices, so you need x equals all this stuff in terms of y. Isaiah? Sure. Natalie?
They always give you like the words perpendicular to x/y axis.
No, they could say it's parallel to this axis or whatever, because y'all always get them wrong. And part of the AP test is, well, no, it's, okay, I'm sorry, you guys should know what parallel means. But what you get wrong is you don't read. So it's not math at all. And a lot of the AP test is checking how well do you read. And like I said, the one question I got wrong, which I know this material, I really do. Maximum, minimum, those 2 little letters, AX versus IN. Yep. Read all of the word, not just minimum. It does not mean minimum. Okay, so that's what we've done in the past. Today, we're going to start to spin things. I have released some videos on AP Classroom if you guys wanted to watch them. Today, we're also, your homework is a worksheet, but the worksheet is problems from the textbook. So there's that. So what we're going to start with is spinning things. So with the whole, why do we need to know this? Lots of things in anything that's mechanized spins. If you like your car to work, things in the engine spin to make the tires then spin, that then takes you to your dance recital or whatever.
Controlled by a wheel. That's good.
Controlled by a wheel that spins, though the steering wheel's not quite so
Okay,
exciting.
I was.
But I got you. So, stuff spins often. Propellers in a plane, things in an engine. Stuff spins. So, if I wanted to find what does this solid shape look like, if I take a skinny little cross section and twirl it, the area of it is a circle. And I'm looking for my handy dandy circle spinning thing. High tech. But in geometry, there was this tiny little 2-day section where they're like, oh, here we have this stick with a triangle on it. What shape's going to be made if we spin that triangle around the stick? A cone. Every single cross section, though, you're right, every single cross section is a circle. Carson, what kind of shape do I get when I spin a rectangle around that stick? Cylinder.
Crazy.
Okay, and sometimes the questions are, here's this stick and a circle. What if I'm spinning this circle around this stick?
Ring.
What?
A ring sphere.
A ring? You get a donut, you get a bagel, depending on, what time of day it is. It's a bagel in the morning and it's a donut in the afternoon.
What? That doesn't make
It's a toroid, it's a Cheerio, what?
I don't understand that.
Okay, if I take this
No,
circle,
I understand that. I understand why is it a donut and why is it a bagel.
well, because, depending, you guys are in high school, it depends on what kind of food you're hungry for. Very early morning, it might be a Cheerio.
Very early morning.
No, that's what you do at like midnight.
If you're gonna like sass, I'm better than you, so.
Oh.
Anyway, all right,
Recording today?
what?
Are we recording?
We are.
Yay.
Please never do edits.
You're the people at home, by the way.
Okay.
I'm better than you.
I have 20 plus years of teenage sass under my belt. I'm like, oh, I've heard it all. Heard it all. Step back, yo. All right. So if I want to find the volume of a shape that's changing, like, I don't know, maybe it's a Hershey's Kiss laying on its side, and I happen to have the equation of, guys, I have the equation of that Hershey Kiss. If I then spin it and do super skinny slices, by the way, that means integrate, the area of every slice, I eventually get this solid. And, if the slices are fat, I'm going to get this chunky thing. But if I make the super skinny slices, I get this smoothed over shape. Yeah.
So like there are derivatives and there's integrals. Is there like other stuff that you do in calculus?
It's all a matter of, calculus is the rate of change. How is this behaving as that other thing changes? And you can get fancy and have 3-dimensional things like as the X and Y change this way and the plane lifts off in the Z direction and then there's wind, cross shear, stuff. Things happen. Okay. Can you guys write this down though? For our things that spin, finding the volume of that shape, it was the area of our cross section. So the same thing we did of our known solids. Area of a circle is pi r squared. So find the radius. The radius was given to us as an equation. And so it is pi r squared integrated from a to b. A to b is defined in the problem somehow of like, I only want this slice of time. Let's focus on it. You don't have one. That's as fancy as it gets for the moment. But you know me, there's gonna be something.
How does this relate? I think that's supposed to be like the equation, like the function that marks the outline of the shape. like the Hershey Kiss up top, that arc
Yeah,
is, that arc is R of X.
That makes sense.
Radius.
Higher square? So Carson, you get it? So it's like I don't hear your question.
Wait, so you don't need to find the base or like the height anymore?
Okay, so the last things we did was like, okay, here's this function f of x, and maybe here's this other function g of x, and this is the base of some weird shape, and stuff is coming up out of this shape that are, let's call them isosceles triangles, where the hypotenuse is in the plane. So I needed to find the area of that shape. So find the area of the triangle. It's kind of a pain because the hypotenuse is there. F of x minus g of x divided by 2 and stick a root 2 on it. But this one, every slice, when you have a shape, my fancy toy, you have a shape and you spin it around a single stick, every single thing is a circle, right? Really, people? You are so easy, people. Best dollar I ever spent.
How do they kind of
Where did I get
separate?
it? I got it at the Jazz Fest in New Orleans in like 1986 when I was in high school. And it still works. It's a spinning.
WD-40 twice a year.
Not at all. And this is made like from recycled God knows what. Yeah. But worse, because like
Yes, Jen, please do that project after
you can make them yourselves to make yourselves happy because you guys seem like really thrilled with this.
I am.
So, but every slice in there was a circle,
That
right?
equation is finding it and then spinning like around.
So the volume. To find the volume of every slice, like this one, every slice was a triangle. A specific kind of triangle that had to be defined in the problem. These guys, when I just say this shape is spinning, you're going to get circles. Like any shape,
Okay, I understand.
any shape you spin, that guy is going to be, as Carson said, he's going to make, on the geometry test, you guys are like, that one's going to be a tuna can. All right. This one's going to be, a cereal box. I'm like, no, you can't spin and get a rectangle. It doesn't work that way. That one's going to be a doghouse. No. It's going to be a rocket. So, all right. Let's look at the, cool. Let's look at some problems.
Wait, so what exactly is Rx?
Is it just
It's the equation of the curve
Okay.
that defines the outline
So
of the shape.
this question here.
What if it's,
Hold
are
on.
we gonna do this with the area between two curves?
Look at the question that we have at hand right now. It says the function is the square root of sine x. And the square root of sine x looks just like sine x. So at 0 and at pi, and then there's an arch. Okay,
Of the values?
so there's this thing, and when I spin it, it's going to look like a rugby ball. Okay? So every cross section is going to be this circle. Eric, what is the radius of that circle?
That is square root of sine x.
The square root of sine x. Do you guys agree?
Oh, I understand.
How are you wearing sweatshirts? The rest of us are like
Yeah, I'm feeling
sweating.
It's harder than the blue. It's harder than blue my days outside. I just got here. That was great. It was cool. The mom had
Okay, so the radius is the distance from here to the curve, which also happens to be the function itself, right? Because the function to down below, that y equals s of x. Okay, so Roisin, what is the area of my cross section? Pi squared, so if that's r, if this is r, what's the formula? Pi times sine? Yes?
Oh, do they just, oh, they cancel it?
Square root of
Yeah.
stuff times square root of stuff is just stuff. Okay, so Sam, I have the area of the cross section. To get volume, I need to integrate. I need to find all of the areas and add them up. So what do I?
Pi, and then the integral from 0 to pi of sine of x dx. Which is,
Okay,
I got this.
Kian, what is the integral? Whose derivative is positive sine? Negative cosine. Okay. Iris plugging in the top one. What is cosine of pi?
No, sorry.
Negative 1. But it's negative 1, which is positive 1, right?
Yes.
This was pi times negative 1, and then we are subtracting. Liv plugging in 0, cosine of 0, 1. Minus a negative 1, right? Sorry. Am I doing this backwards again?
So it's minus. Minus.
That's right.
It was just, yeah, minus
pi,
negative,
right?
yeah.
Yeah, I got 2 pi.
Because plugging in the 0 to cosine, we got negative 1, but it was a negative 1. So
Is it
the rugby ball has a volume of 2 pi. Ooh, yeah. Okay. So really, like, supposedly these are easier because every shape's a circle versus the things, the shapes that popped up. Was it a square? Was it a triangle? What kind of triangle? These are all going to be circles. Okay. Now I can be mean. You guys know that already. No, yeah.
I'd love it if you weren't though.
I know. Well, you know.
Hey, true.
Okay. So we need to be able to graph this thing. 2 minus x squared. What does that look like? Jacob, what does it look like? Parabola. Is it a up parabola, a down parabola, a sideways?
Down parabola.
A down parabola, frowny face. Okay. What is the high point? 2. So
It's in it.
when x is 0, y is 2. When x is 1, 2 minus 1 squared.
Wait, when does it open to the right?
Y equals x squared. So this is a downward facing parabola. And it says we're going to take that curve and g of x equals 1. Josh, what does the graph g of x equals 1 look like? A line with a slope of 1.
Oh, wait, no.
I mean, yeah, there you go. So it says take those two curves and we're going to spin it around y equals 1. So this is like the rotisserie. It's spinning there. Okay? So again, it's kind of like squished basketball. Just a little bit. Yes.
So for f of x, you wouldn't include anything below 1?
So find the volume of the solid formed by revolving this region, so the frowny face, and the straight line, so whatever's pinched between those two, which was
What
this
is
stuff.
the domain?
We haven't done that yet.
Intersects, that makes sense, actually.
Oh, I think I know.
Okay, hold on. So are we okay with the picture? So Sydney, like, we're not gonna do stuff beyond that because where I made the dotted lines, that is outside. It's not pinched with the straight line, the horizontal line. Okay. These are all circles. The hard part, Asher, you think you know what to do? I need to find the radius. What is,
1 minus x squared.
how do you get that?
Top minus bottom.
Top curve, which is 2 minus x squared, minus the bottom curve. 2 minus 1 is 1 minus x squared. You guys okay with that? Okay, hold on. So yes, that's perfect. And I've had other students say, well, can't I just like shift this down 1 and then use that as the radius? And I'm like, okay, sure, go ahead. Shift it down 1. So then I get 1 minus x squared. Oh, it's the same thing. Yes. So it's, if you see it as like, I want to move this whole rotisserie down, so I'm going to have to take 1 away from that guy. Okay, knock yourself out. Whatever works. So Asher, how are you going to finish this?
You'd have to square it, like, and then yeah, that's it.
Square it.
I put the integral too.
Okay. Okay, yeah. Oh, so actually, what is the area? Area is just r squared?
Pi.
Pi. Just letting you know.
Yeah.
On multiple choice, A, the first option is the correct answer without pi. B, C, D, probably more like D is the right answer with the pi on it. But we want to find the volume, so pi r squared. Can I put the pi on the outside?
Yeah.
Okay.
Yeah.
What are the bounds?
Negative 1 to 1.
Negative 1 to 1. Is this also correct? Where? Oh, sorry, I dropped the pi, so no, it was not correct.
Yes.
Is this now also correct? Okay, what's, all right, if I needed to do this by hand, this is how I do these. This little eggy football thing, is there a symmetry on the right and the left? So if I integrate from 0 to 1 and double it, I get the same answer. And it's easier by hand, plug it in a 0, than dealing with negatives. Eric, yeah?
Just try to look. Wait, you can just keep pi though, right? Like it's.
So take out your calculator and see if you can type this in and get a number. I get 16 pi over 15. Which is 3.351. Okay. And just to show you how I did it by hand, squaring this out, if you guys don't get 3 terms, please do it the long way. and do the A minus B times A minus B, first times first, outside times outside, inside times inside, last times last, Griffin, what do you? I've now merged your first and last name, and you are now named Griffin. Yeah, okay, what's the question?
I don't know, I was trying to figure, what's the whole bottom section?
Okay, this here, so I integrated. Here I expanded that so that I
Were
could,
to do by hand.
yeah, so I don't know how to integrate this by hand. I can't, I have to expand it. Then integrating 1 to x, raise the power, divide by the new power. Don't lose the 2 pi. Evaluate from 1 to 0, thankfully plugging in 0 to each of those, this all goes away. So then I had to do the challenging arithmetic of 1 minus 2/3 plus 1/5. Yeah. Okay, we might end up spinning around the y-axis as well.
But like, will you solve those?
Okay, we'll do one of those in a minute.
Oh,
Yeah.
well,
Can you explain how to find the radius again?
How do we find the radius? Ashley said it's the top curve minus the bottom curve. The top curve here was this equation, y equals 2 minus x squared. The bottom curve was just 1. The radius is the distance from the top curve to the bottom curve. 2x squared minus 1, 2x squared, 2 minus x squared minus 1. Combining the numbers, good?
Yes.
What else? Well, question? No? You sure? Andy, how you doing? Good times. All right. So there's those. Now we gotta try these. Yeah. So this one, let's look at it. Find the volume of the solid formed by revolving the region. Okay, sideways parabola. X equals y squared minus 1. That's this. Okay. This thing is x equals y squared minus 1. That's the y-axis. This is the x-axis. And we're spinning it around x equals -1. Woo. Right there. So the shape we get when we spin, does anyone have a visual of it, what it might look like? Yeah?
Just endless or
Isn't it what?
endless?
I'll
be.
Okay.
It's like a cylinder with like.
So about the line y equals 1 and
It's a yo-yo. It's like a really, it's like a.
so those
It's like
three
a
things,
cylinder
those
with like
three
one
lines, it's got to touch all three.
Where's one side?
Here's y equals 3,
Oh, okay.
this line. So Kian, it looks to me like
Yo-yo. Oh, it's that.
that's
Oh.
that's the space that's cut off. That's where all 3 lines. No,
I don't know, it's one point you said.
I mean, do you guys agree? They told me 3 lines, a horizontal top line, a vertical side line where we're spinning around, and then the curvy bit. All 3 touch and make that shape. Because do I include this part? Did that like I think no, because what's the question?
No, Carson was asking if y squared minus 1 would be here's the down one, but I'm telling you it's not. It's y, not x.
Okay. And this is spinning around this line. Okay. So this is gonna look like a really fat funnel. Yeah. Well, as Kian was saying, if it does go to this, he's saying it's boundless. I didn't have a bottom of it. So it doesn't have any bounds if I let it keep going. Right, wherever it's constrained. All
How do
right,
we,
Yeah, you find that accelerator.
okay, guys, here's the trick to this one. Are the slices, the thicknesses of these that I need to integrate with respect to, are they dx slices or are they dy slices? dy slices. Every thickness here is dy, so I need my radius in terms of x equals stuff in terms of y.
But where's the,
Here's the radius I need to find. I need this curve as x equals stuff in terms of y. Do I have that already? Yes. Okay, and the thing it's spinning around is right here. To get the radius, what is the distance between this curve and that line?
Y squared.
It is the right curve minus the left. So just y squared. That's the radius. So Indy, what is the area formula of every circle?
Pi r squared.
Pi r squared, so pi that squared,
Yeah.
which is what?
Y to the fourth.
So y to the fourth pi. Ananya, what's the lower y bound?
Zero.
0. Francesca, how do we know it's 0? Where do these guys intersect? Where does x equals y squared minus 1 equal x equals negative 1? It's when y squared equals 0, which is when y is 0. Keith, what is the upper number? Yeah, we're gonna go from 0 to this top. Where did 3? So it's actually a pretty clean equation, just it's hard to get the answer. Madam, how do I integrate that?
So you make a bar, you can leave pi on the outside. So y is 5, the fifth over 5.
What numbers do I have here?
0.
0 to 3. 3 to the 5th, 243. Minus 0 to the 5th. So 343 over 5 pi. Okay? Spectacular.
That actually makes a lot of
Does that
sense.
make some sense? All right. Okay, the homework that I want you guys to start now because I want you to have practice with these problems. Here you go. I even put it on a sheet of paper.
Yeah, what's that? Hanging out.
You guys get one now? Isaiah, wake up. Okay, don't put it away.
No, I'm putting this away. Things that I received back today.
Okay, the answers are on here as well, so you can check. But, and number 35, you can't do all 4 pieces, but it's up to you to figure out which ones are gonna be a challenge, and we'll do some of those tomorrow. Draw the question.
Wait, what is this line in the middle of 14?
Okay, so this is what 14 and 15 look like, not photocopied. So it's asking you to find the volume of this, what shape's gonna form when we spin this around.
The whole thing is the line separating.
It wants the whole thing so from 0 to 2. This is trying to show you the radius is that pink stick
Oh, that's so.
because it's rotating around the y
Oh.
axis. So they were trying to be helpful and it doesn't photocopy well. These are out of your textbook. Thank you. Yes, lovely. Good idea. Francesca just shaded them in.
So the radius always is perpendicular to the axis of rotation.
Yeah. Has to be. Otherwise, it's a really wonky thing. Number 15, I don't expect you to integrate it by hand. It can be done. I don't recommend it. You can type it in on a calculator, but I want to make sure that you can do that. Do you guys need help setting it up, or are you guys good? Okay, good talk. We'll go with that.